Everyone, you are welcome to another session under the metalworking. So last class we discussed about the metalworking tools, where we made mention of classification of the tools with respect to hand tools and power tools. So today I would like to lecture you about the metalworking processes. Metalworking processes, you are welcome on board. So the metalworking manufacturing processes are classified into 5. We've discussed about it briefly under the introduction to metalworking. So now is the time to discuss about it comprehensively. Metalworking processes are classified into 5. Number 1 is a processes used primarily to change the shape of metals. Number 2, processes used for machining parts to plain dimensions. Number 3, processes which change the physical and mechanical properties of metals. Number 4, processes used in joining parts or materials together. And the last one is a processes used primarily to obtain a surface finish. Number 1 of it is a process used primarily to change the shape of metals. So the shape of metals, of the metal, can be easily transformed through casting, forging, bending, rolling processes, among others. So when your metals are in plastic form, that is in a soft form, it can be easily deformed. So the first one here is casting or foundry. You can call it foundry or casting. So you can see the blue line here. This blue line indicates the liquid metal, the metal that has been softened into multi-form. That's been heated and softened into a multi-form. Now they pour it inside the mold. The complete one here is a mold. So when they pour a multi-metal inside the mold, after the solidification, the metal will take a shape of the mold. That is casting or foundry in engineering. And also forging. This is a forging, whereby forging we have it's simply referred to as a smith. We have goldsmith, blacksmith, and other smiths, in which demand for the heating of solid metal in a furnace or in a forge to make it to be in plastic form that will be easy to bend easily. This is a forging operation. And also metal can be transformed, the shape of it can be transformed through this form here. This is a forming method, in which normally in our area, if you go to a site, production site, the construction site where they are constructing a building, you will see iron bender there. Iron bender, they used to bend iron to different shape. This is part of the process of change the shape of metal. The metal can be, you can change it to rectangular square shape or round shape like this one, to any form you want. And this one is also a rolling process. You know, see this is stock material here, and also it's rolled, it's compressed down to form a sheet metal. This is how the sheet metal is formed. So all these processes here, they are referred to as processes used primarily to change the shape of metals. Are we together? Next one is a processes used for machining parts to plain dimensions. Processes used for machining parts to plain dimensions. So the metallic parts can be machined to plain dimensions with some subtractive manufacturing processes like turning, shaping, drilling, boring, and sawing. So the picture here represents the turning operations. This one represents the turning operations, whereby this one represents the milling operations, and this one represents the planer operation, and this one final one represents the shaping operation. The machine used for here is called lathe machine or turning machine, whereby the machine here is a milling machine, the machine here is a planing machine, and the machine here is a shaping machine to shape your material. So all these operations that are taking place here They are referred to as processes used for machining parts to plane dimension. The operation of it, I will show you the video shortly. Also, you are welcome to the processes which change the physical and mechanical properties of metals. Processes which change the physical and mechanical properties of metals. So all this one, the mechanical properties of the metal can be altered by its treatment, cold and hot working processes. We've discussed this one under the engineering materials as the factors that affect the material. So this is a heat treatment, and this is a cold working, this is a cold working, this is a hot working. For the heat treatment of different type, we have annealing, we have normalizing, we have hardening, we have many of it in which you can alter the physical and mechanical property of metal easily. So for the hardening, if your material is very soft, material like metal, if it is very soft and you want it to be hardened, you can harden it by which way you insert your material into a furnace or into a forge. You let that material be heated to Austenite temperature. When it is heated to Austenite temperature, it will give the microstructure of that material free movement to move from one place to another. They will easily move around. So when the material is heated to Austenite temperature, you now quench it. You insert that material into a quencher. Maybe you quench it with water, brine solution, or you quench it with oil. By quenching your material with water, the quencher, or oil, it will drastically harass the movement of the microstructure inside the material and make the material to be hardened. It will make the material to be seriously hardened. In reverse, if your material is very hard and you want to make it to be softened, the process for that one is annealing. You subject your material to annealing process. In what way? The same material or another material that you want to work with, maybe you want to machine it and it's very hard for the two to cut. Don't throw away the material. The best way to do it is to soften it by annealing method. So that material, again, you put into the forge or into a furnace. Let that material be heated to Austenite temperature. So when the material is heated to Austenite temperature, it will give the material opportunity, the microstructure inside the material opportunity to move around easily. They will be free to move around easily. And you take that, you remove it when it's reaching the Austenite temperature, you remove it from the furnace or forge, put it down, and let it cool down with a steel here. So the free flow of here, let it cool down. When the material cool down in such a way, the material will be softened. It will be annealed. It will be softened for you to work with. So because the microstructure inside the material, they will easily and they will settle down conveniently. That is the difference between the annealing and hardening. So during the hardening, the microstructure, when you quench it urgently, emergently, all the microstructure, they will get stuck accidentally and the behavior of the material will be hardened. But when you heated it the other way, in order to soften it, and the microstructure can easily settle down conveniently, the material will be softened. That is the difference between hardening and annealing. So for the normalizing is when you have material and the part of material, maybe you have 10 cm of material, 10 cm of material, you have it, and part of it, maybe 5 cm part of it or 3 cm part of it is hardened. 3 cm part of it is softened, is annealed, and 4 cm part of it is not balanced. In order to make the material to balance, either to be in a hard form or to be in a soft form, you subject that material into normalizing. So the microstructure, they will flow together and be in one part, either to be hardened or to be softened. So the material will be normalized. The microstructure, they will flow together and make the material to be in one part. That is what I mean by heat treatment. Video of it will be shared to you. And between the hot working and cold working, the hot working is when your material, you are working with your material, the material you are working with, you subject it into heat, you heated heat. Example of it is forging. When your material, you heat it in a forge or you heat it in a furnace, and your material is red heated, and you work with it, is referred to as hot working. So the hot working is carried out above crystallization temperature, formation of new crystal form, surface finish is not good, no residual stresses, and less force is required. Less force is required to shape your material to any form you want when they are in hot working. And also when you are cold working, your material is not subjected or is not heated to hot temperature at all. It's in a normal form. And when you are working on it, you work on cold working below crystallization temperature, no formation of crystal at all, surface finish is very good, formation of residual stresses, and more force is required whenever you are cold working in order to change the shape of metals. So all these processes here, they are referred to as processes which change the physical and mechanical properties of metals. The video about it will be given to you during this session. Next one is the processes used in joining parts or materials together. Processes used in joining parts or materials together. So the metallic parts can be joined together with welding, soldering, sintering, and mechanical fastening processes, among others. When your materials are in parts, your metals are in parts, and you want to assemble them together to be in a single unit, just like apparatus you are using in the lab, like lens solder, not lens solder, optical bench, Hooke's law apparatus. If you check them very well, you see that, or sonometer, if you check them very well, you see that they have different parts. They have different parts in which they assemble them together to become a single unit of apparatus. So when your materials are in parts and you want to join them together to be in a single part, a single component or single object, all the processes that you use to join them together, they are processes used in metalworking. Number one of it is welding. You can see this gentleman is carrying out welding. So it's carried out, this one is oxyacetylene welding. It's carried out welding here. And also gas welding, oxyacetylene welding is carried out to join metals together. When we get to welding operation, you know the different type of welding. We'll talk about it extensively. And also this one is a soldering. Soldering, whereby you use solder to join two metals together. Two metals or two parts together. And this one is where you make use of the fasteners. This one is a different type of bolt and nut. When to fasten your materials together, different component parts together, you make use of the fasteners. This one also is a fasteners. And also sintering method. Sintering method, example of the sintering method or explanation regarding the sintering method is when you have particles of metals or iron filing, there are many, you can make it to be a single metal back, to be a stock material. In what form? You compounding it, all the iron filings, all the particles, you compound it together in a mold to form a single metal. So the method of joining metals together, sintering is part of it, and mechanical fastener are this one. So all the processes here I made mention, I discussed about, they are processes used in joining parts or materials together successively in metalworking. So the last Process is used primarily to obtain a surface finish. Process used primarily to obtain a surface finish. After you've produced your material or you have produced your project in the workshop, you want to protect it against rusting. You want to give it a fine surface finish. All the process here are the one you are going to employ. So the metallic part surface can be achieved perfectly with polishing, electroplating, parkerizing processes, among others. So polishing is when you use emery cloth to make the surface to look fine. You polish it with smooth sandpaper or emery cloth. That's a polishing. Electroplating is you carry electroplating as in electrolysis in chemistry. You coated it with another material. If your object you produce or the apparatus you produce in the workshop is made up of milestone, and the more it's exposed to environmental conditions, the more it corrodes. In order to prevent it from corrosion or environmental reactions, you electroplate it with another material in order to coat it. And also parkerizing is another method of protecting the surface of metals against rusting. Thank you very much. This is the end of the manufacturing processes, metalworking manufacturing processes in engineering. Thank you very much. All the videos that are relevant to all the processes will be given to you one after